All right, 7 o'clock. Let's get started. We have done all the reviews until lecture 4. You know how to solve the problem in lecture 3. And then we use time and space complexity to judge our solutions. Of course, there's also the issue of practice versus in theory. And the other topic about UI UX, which is not in our course, so we ignore that part. Now, once you know your solution is good or no good, but then you want it to be correct too, all right? So are you sure it is correct? So debugging, which is a good break from all the other lectures. This lecture is actually very straightforward, just pointing you to what are the pitfalls that you may have encountered, and you have to pretty much learn from experience. Of course, this is about Python. So Python has all these various issues that you have to catch. For example, the use of the tuple, you must have a comma if there's a singleton in there and so on. On the other hand, this is not propagated to other languages. So there are things which are specific to Python. There are things which are generic to all programming languages. And on top of that, actually, you also have eventually work with libraries, and the libraries are actually things that you have to watch out also. There are certain characteristics of those libraries that you have to know. So when you use them, you know that what could potentially be the issue when you use them, so that they can catch program bugs very quickly. Okay. So let me just repeat some of the stuff that we have gone through. One thing about the thing that we talked about last week was the correctness is not the absolute correctness. It is the correctness with respect to a certain assumption. I pointed you to the problem of a millennium bug when you keep year in 2 digits rather than fully 4 digits. All right. So that you should know. Okay, so for today, I want to go through some of the things that we do to understand a program. As you know, the program has syntax versus semantic. Syntax means that it met all the Python requirement. It doesn't, you must have a proper indentations, you must have a colon after the if statement, the for statement, etc. On the other hand, semantic, it's the thing that it's actually what that program is doing. You will have to learn that. There are very few of us who can look at it and understand it in one look. We generally have to do tracing, okay, meaning that we try out with small program to a small input to understand what is the outcome of the input, and then from there we deduce what are the things that this guy is trying to do. Okay, and then the program, as you know by now, there are three parts. One is a sequential statement. Okay, the other is a conditional statement. All right, and last but not the least, the most difficult one is the looping. Okay, for sequential statement, the common bugs that I have listed in the lecture also that you can find out. I looked through this and it's quite consolating to me myself that some of this stuff actually are collected from the past experiences, and I really get refreshed and understand it better also. Okay, for sequential statement, there's possibility of we misinterpret our operator. For example, this guy percentage and this double line is integer divides. They are all very. The one is talking about the result. One is talking about the remainder. So at times we just mix them up, and then that cause problem with our program. And also string and tuple, which they do behave pretty much close to each other. The behavior of string and the behavior of tuple they are pretty much the same. So things that you can do with string, it's likely that you can do with tuple. All right, and both of them are immutable. Okay, let's see what I meant. For example, so let me. Okay, so this is so for string, for example, you have a string is equal to A, B, C, D. All right. So if you use A, B, C, D and the fifth element, or actually five means the sixth element. There are only four elements here. If you do that, you will get error. All right. So it's a string index out of range. It's the same for tuple. So if you have a tuple which is 1, 2, 3, 4, and then if you try to do 5, you got an error because the string and the tuple they behave pretty much the same. On the other hand, there's tricks that we play. Instead of asking for the fifth or even the fourth, all right, because there's no fourth, which is the fifth element, you got error. But if you ask for from fourth onward, actually you got an empty string. Okay, so this is the kind of thing that you have to remember. It's peculiar to Python, or it could be, it's quite meaningful in a way. You have to remember. Okay, so there are things of a sequential statement. You have to watch out for things about the behavior of the different type of data structures. As for conditional statement, one thing that of course you know is the indentation, and also you know about the precedence rules and those things that you should take care. And in general, we hate this kind of statement because you write program for other people to read. But by writing it in this manner, you assume that the guy will know that this is right associative. But this is not very friendly. The guy has to interpret in his mind to know that this is 3 to the power of 4 to the power of 5. And so this is not so friendly. If you want, you should bracket it, parenthesize it. And another important thing about conditional is that be careful when you're using floating point number. As you know, and I illustrated, floating point numbers are not exactly represented as what you would understand. 1.2 could be 1.1999999, okay? So in the use of floating point number in the if statement, that is very dangerous. Usually you may not hit that. If you use the exact equality, usually we will not want to use equality, but we'll use less than. Even with that, that is also very tricky. At times that you may just miss by one long decimal point at the end. And then looping, for looping, recursive and iterative, and you have to be proficient in both. And the tricky thing for us is that recursion, you know that there are always base cases. And how do you know that your program will hit those base cases? There's this thing in the mathematics called the partial order. All right, you will learn that in discrete mathematics. And once you follow partial order, starting from the larger guy in the partial order manner, order, you know, right? Usually when we talk about order, it's a full order. Partial order means it's some can be compared, some cannot be compared. But there's no looping around an issue about this guy larger than that, that guy larger than another one, and that guy in turns be smaller than this, and there will be a looping. All right, so as long as you follow partial order, and you will get the base case, and you always get to smaller problems. Then iterative, again, iterative, it's also at time it's a little bit tricky. I have some example here. All right, so for example, this iterative program. All right, so how do you know that? So your j equal to 0 for j for I in range 2, comma 100, comma 3, j plus 1, return j. So semantically, you know that this j is to keep track of the number of loop that you have. So when you print it, the result is that you get 33. So somehow, you have to, when you do iteration, you must know how to do calculating what this guy is. So how this guy is, so we will have to do, for example, here, you will know that the I will be from 2, starting with 2, and then become plus 3, right? 5, and then plus 3 become 8, and so on until who is the last guy? The 100 means that you cannot reach there. Then it will be 99. But if it is 99, increment of 3, you will start from 1 rather than 2. So from 2, you can only reach at most 98, right? Uh, okay, 98. Let's see. Okay, so the last one is 98. And so if this is the case, then you know that this is very difficult to count. Counting, as we learned last week. Also, you can remap this. This become 1, this become 4, this becomes 7, and this become 97. All right, so now the chance of calculating what is J is that from 1 to 97, how many are there? So you can simply use 97 minus 1, all right, the last guy minus the first guy divided by 3, and you will get 32, okay? So 32 means that you, from this guy all the way to here, there are 32, there are 32 of them, but counting is such that you have to plus 1, all right? So there are actually 33 terms, okay? That's why you get the answer as 33. All right, so these are the things that you have to learn to be able to manage. Okay, so this is tracing. So tracing is to find common bugs or to understand the semantic. Now, to do tracing, at time, of course, it is human hand tracing is always very time consuming, and sometimes we mess up things. But in tests, you got no choice but to do that. But if you have a computer with you, printing statement is always helpful. All right. So with printing, you can do tracing very well. So, for example, here you could actually do, you can print I. All right. Then you will see the I get come out, and all right, it's 98, right? The last guy. Okay. So that it's also helpful with printing. And more than just printing, when we talk about tracing, we at time, or debugging in general, we invest in extra function. That means that you write some extra code to help you to trace, to do automatic testing. And I cannot help but to emphasize this various times. In the last few reviews, I also say that we do have to invest in writing program codes which are not part of your delivery, and but that helps you with saving time in debugging. Writing code is just a matter of a few minutes, but debugging, it's all the time it takes. All right. The other tools that you can use is Python Tutor, but of course, Python Tutor, as I use it here, you have seen it a few times. They are usually for small program. Okay, for big program, it doesn't help. But of course, this is as a beginner, it is already very helpful to bring you to step through the codes to see things that you may not. It will take you a long time to actually trace. So, but here you can see that you can do, this is a code to reverse a T. A T is the tuple. A, B, C, D, E. The code is to reverse it to become E, D, C, B, A. All right. So you see that it does give you all the codes like this. So this is a function call. When the function call, you get this as an input. The function is repeatedly called. It's recursively called. And you got this because the last one is strip off, and you will stop at the one before last. So you got this. So, and this not only allows you to see how things goes in debugging, as you know, it means to understand the flow of the program. All right, the flow of the program. I think it's here. All right, the flow of the execution and the value changes. All right, so if you can master these two things, then you have succeeded. You have in getting the tracing done. And not to underestimate this fact, this is showing you also what we call the footprint of the codes, the footprint of the storage that in the computer that needed to make this code run. So you needed this space, this space, this space, this space, and this space. Now you see that this code is actually needing all these spaces, and you add them up, you get n square spaces for n as the length of the input t. All right, so last week when I told you about, uh, oh no, not this one, this one. All right, the time is, we trace this vertically. Of course, this code is traced here. You could have traced it with Python Tutor. The time is here, vertically, you add it up, and the space is horizontally. So today what you're seeing is that instead of horizontally, this is all vertically, but this one is one after another. So all these things should be put in one line, or one line like this. There are actually five of them in this defer operation. There are also five here defer operation. They are all one after another that the space needed. For this simple example, you get the defer, the storage is n, whereas this one is n plus n minus 1 plus n minus 2, n minus 3, n minus 4. This is actually n squared. Okay, so Python Tutor is very helpful to help you to see things. Of course, the IDE integrated development environment like the Visual Studio Code and so on may have other ways to help you with the visualization. Okay, one last point here. It's about drawing. So you saw the drawing last week. All right, in this code, you see a simple table as a drawing to trace the code, or the Python tutor way of doing stacking. This is more elaborate. And in actual fact, in the other lecture, I'm going to show you quickly. All right, in future lecture, this is lecture 8. You are dealing with tree, and a tree case, you have to draw things looks like tree, upside down tree in real life. Okay, so different kind of drawing, you will see the ways to help you with the tracing. Okay, don't be stingy on putting down some drawing to help you with tracing. The simplest is a table, but the table doesn't help you in this case because the same variable, they have different values because of recursion. All right. So I also mentioned about the second point about understanding the space complexity through here. So I just show you what I wrote here. All right. So I did say that previously we saw horizontally, but now we actually stack them up here and you have to sum them up. Okay. The next important one that I wanted to show you is to reaffirm you the understanding of time complexity. Oh, by the way, my posting in the forum about practical versus theory, I don't mean to undermine or or to belittle the importance of time complexity. When the time complexity is exponential versus time complexity with polynomial, indeed, they're completely different animals. The one in the exponential, it's not possible to do it in real life. Whereas the one in polynomial, it's always what we strive for. All right. I only wanted to point out that I concur with one of you that both of you in the forum that the practicality is another consideration we must have. Okay, there's this part I want to show you. Find E. The last week we had this question. Write an iterative version of find E. Actually, was the solution for number 5. All right, and number 7, it's this solution I don't like. I don't want to show you, but this number 5 is what we're going to study. So we saw that it's on square and space on. Why is that so? Okay, I'm going to do this thing once, and you should practice this to the question I'm going to post in the forum to see for yourself. It's kind of exciting to me that I can show you by counting explicitly step by step. Okay, here it goes. Right, here's the code. Here's the code about factorial. We are using factorial as iteration, as in question number 5. So this is question number 5. Last week, Q5, recitation number 2. And then we claim that the time complexity is O of n squared, and the space is O of n. All right, the space is not what I'm not going to show you, but you can know that the space it's because of this defer operation. Okay, whereas this factorial is iterative, is constant. Okay, so we see this, we execute this, we find E. As I said, we use a simple number 5, and then we're going to increase this number as we move on. Okay, maybe I can engage you at this moment. So this guy, besides seeing that, go to the last, you see the answer here. This is very close to the answer. So it's using 72 steps. Okay, here's my table. This is my spreadsheet. Yes. You have a question? Daniel. If not, then mute it. Okay. All right, so here's the table. I wanted to show you. So the time here, it's using the input. This n is the input. My input is 0 until all the way lah, but I can only do it until 24. 25, it run out of space. So let's see. 5, it's 72 steps. So 5 here, this is 72 steps. Okay, 72. All right, so it is the data point. So 5 here, there is a 72 here. You see that? All right, we could do the same. Okay, I did the code. Can do 25. Visualize. It failed because 25 is too large. All right, so I need to go back. That's why I say this is only useful for small number. 24. All right, it works. It takes 775 steps. What does this 75 steps? That means that basically you do this, You do this one by one. Okay. At the end of it, until the end, I go to the last. You get 775 steps. That means that at 24, this is 775. Okay, so you can do this, take this code and change it to whatever, 12, right? And then you do again. All right, you will get all the numbers. So 12 is 247. So let's see. 12 is 247. Okay, so we have all the numbers. So all these numbers plotted this curve. All right, this curve. 12, yeah, 247, 24, 775. Okay, so we want to understand this curve to claim that why this is n squared. So how do we do? Well, let me try to call you. So Ajay.
Yes, bro.
Okay, so how do I know the rate of growth? Let's see. Let's see. The rate of growth. So how do I calculate rate of growth? So you know a curve. So how can you
Yeah.
make sense that this guy is n squared? Because we know we deduce is n squared in the last round. How do we know? So
Differentiate.
differentiate. Okay, but all these are real number. How to differentiate? What is the meaning of differentiation? Basically, is to find the gradient at that point, right?
Yeah.
Okay, so let's do that. The gradient of that point is simply taking time t minus 1, and then divided by the base, which is 1. Okay, so this one, the division give you what?
Uh,
9.
9.
16
eh,
minus 7, 9.
Okay.
This one,
Thirteen
27 minus 16.
13.5.
Huh?
Oh, wait, 5.5. If 8, 11.
27 minus 16, 11.
Oh, okay.
40 minus 27,
13.
13. Okay, so we have all this.
Okay.
All right, so we have all this number. So what is all this number? What can we tell? All this number 9, 11, 13, 15, 17, 19. So if we
It's
charge it out, it's here. This green line. What does this green line look? What does it
a
look like?
linear line.
Linear line. Okay. So now you can deduce that from some guy differentiated, you get linear. What does it mean by this guy?
That means it's squared.
Square. Okay. So we take n square. We take the n square
Yeah.
of n, right? So we will get all this number. 1 is 1, 2 become 4, 3 become 9, 4 become 16, correct?
Yeah.
Okay. So how do we compare this n square with this time? So we can take the difference of these two guys, take the time minus away that, correct? Take this
Okay.
minus this, take this minus this. So what do we get? We will get all this number. What does it tell you? Let's plot it out. It's here. Okay.
What is this?
Ah,
This is difference of the squares, is it?
no, this is the square.
Okay.
This is the square. Yeah,
Oh,
this
okay.
one is this one. So the difference of the square, it means what? They are all positive, right?
Yeah.
So it means that this orange color is always lying below the blue color.
Yeah.
But do they look the same shape?
Yeah.
Yeah. So remember last week when we talk about big O notation, we have the K and the N0 to choose. Correct?
Yeah.
The K is to allow us to be a poor man, and yet we can artificially make our curve higher, right? The N0 is there to help us to say that anything below it, I don't care. Anything after that, that I won't worry about it. Okay. So now you see, how do we claim that this guy is n squared? We would have to choose the appropriate k and the n0, correct? To move this guy up to to make him higher always than this blue color,
Yeah.
correct? So what
Yeah.
can we choose? Our k.
Add the red line and the blue line together.
Add the red line and the blue line together. Uh, while that will okay, of course it will be larger than the blue line, yes. But even simpler one will be you multiply with 2. What do you get? You get this, okay?
Okay. Okay.
All right,
Yeah.
all right. Then if I now take the difference of the time with this column multiply subtract this column minus this column, what do I get? I will get this. Ah, now I see some positive number, which means time is bigger than him. But then it start to become negative number. Correct?
Yeah.
Okay. So here is the the like break point from the positive change to negative. So if you curve this guy, you will see this is the 2n, all right? All right. So here, somewhere here.
So -2 is the O
The
and wait, what's that? The
-2 is because 160 minus 162 get you -2, which means that this is where the curve cross. All right. So this gray color is this column is a gray color. This is a gray color. Okay, this is a gray color. The blue color is this one. This is the blue color. Okay, and the orange color is the. Sorry, this is the orange color. This is the A. Ah, this is the difference. Sorry. So this is not the gray. It's not the gray. The gray is here. No, the gray is this one. Okay. All right. So now we see that we have found a curve after this point, which is the point 10. We know that it is always on top of him.
so 10 is N0, is it?
10 is N0. Ah, okay. Now the question is, what is the N0? Okay, you choose, let's say 9 is 9 is here, minus 2. Sorry, minus 2 is already 9. No need 10.
So it's somewhere between 8 and 9.
Yeah, so we can choose N0 to be 9.
Okay.
All right. So we can choose our N0 to be 9. What about our K? Come with black color. All right. What about our K?
Uh,
Hmm?
it's Is
So
it
our
the
K,
K1?
all
Do
right,
you just
K is actually 2. K equal to 2 will do. All right. So when you choose K equal to 2, then N0 equal to 9, you get this guy. Oh, I should curve it for you. So this guy is also there. So I should curve it. This one is there. Okay. Okay. All right. Sorry. This is N. Oh, this I already messed it up. This is the blue color. This is the one that is the gray color. So the k equal to 2, it's good enough because when k equal to 2, you have this row. All right, that the time is 160, but the 2n square is already 162, which is above him already. So when you
okay?
subtract it, you get that. Okay, so this I should get k equal to 2 and n0 equal to 9 to establish the fact that at least from what you see, this is going to be getting negative and more negative, but I cannot prove it anymore because my Python tutor stopped at 25. All right, if
Okay.
you have a better machine or whatever, better Python tutor, you will be able to list this down and then you will see this number getting bigger and bigger. All right, that means that this two curve is going to diverge much bigger. But whatever it is, you see that this curve and this curve, they are both, this curve is this one. This is the
Yeah.
orange. All right. Okay. Orange. All right. This gray and this orange is going to sandwich this guy. So if you follow our this theta notation, K1 is 1, K2 is 2, you also get this condition satisfied with the N0 equal to 9. And therefore, this function, this blue color, is indeed the theta n square. square in our example here. All right?
Okay.
Okay. Okay. So, of course, here is another, so I'm going to illustrate to you. Because of the k, you choose a small k, 2k equal to 2. If you choose a k equal to 3, again, it will still be correct. All right, k equal to 3, you will get even bigger number. All right, these are the numbers you get. Okay, so this number, if you get, you do the same. You can subtract the time taking away from him. You are going to get even bigger number. All right, but it doesn't change the fact about it doesn't change the fact that it's also the bounding in this guy just even higher, and therefore you can choose your k to be smaller. So in this case, so your n0 to be smaller. So your k is now equal to 3, and your n0 can now be smaller to be 5. At about 5, you can already cross the blue color. All right, so this is still saying that the constant k, if you choose 2, it works, but if you choose 3, it also works. All right, so the k, in this case, it only affect the n0 to be smaller. Or, of course, if you choose n0 to be 9 here, it still work. All right, because you chop off at 9 here at this moment from this point onward, this looks like yellow color. It's already above the blue color. Okay. So far, is it okay for you guys, Ajay?
Yes, Prof.
Okay. So let me illustrate this further. So you can see that if you are not happy with n squared, you will choose n cube. So what is n cube? N cube means that you get all these numbers. So 9 to the cube means 729. Right. So let's highlight this, right? Okay. And so n cube, you see that n cube is going to be here, and let's graph it out. N cube. All right, you see the n cube, this blue color. Okay, the blue color. All right, and it presses all the thing down. So what is this? This is a good bound, but it's not tight. All right, last week when we talked about complexity, the time complexity, if you give me n to the 10, it works also, but it doesn't make sense because it's not tight. And what we want is usually something which is closest to the actual fact. In this case, it's n squared. So NQ works, but it doesn't serve our purpose. You see all the guys become compressed down to the bottom. Okay, so I should disable it. Okay. Then you can see the rest of the curve. All right. So this is what we have for this code. Okay. This code is n squared. And in your exercise, homework, write an iterative version of find E. All right, so I intentionally didn't give it to you last week, but you can see it here. Here is the answer I have. Oh, uh, this one. All right, so this is the answer for this guy, which is different from here. So now we want to understand this. So find E, let's quickly find out the answer. See whether this guy works or not. So this 2.716 is the same as before. If you try 25, Oh, this time 25 can work because it doesn't use so much space. 2.718. This is very close to the answer. So this code is correct by example. Of course, it shouldn't be the case by example. But here it's good enough for our purpose. So what I did, I could have done it with 12 also, all right, that you saw before. I will get similar answer, and now I get 45 steps. I did the code. If I use 24, I get 81 steps. So now back to my spreadsheet. Okay, so here's my columns. This column I didn't show you, but let's just hmm, oh here. So the 24 is this row, 81 step. Okay, 81 step. And just now we had for 5, 24 step. For 5, 24 step. Okay, 24 step. So now if I curve this, let me see whether I have the curve. Somewhere here. So I should disable some of the curve. Okay, so it's this line. Okay, you see that this line is highlighted here. Now you see this is very much like the growth just now, which is the green color, the growth. All right, and maybe I disable it. All right, so this is the first find E that you saw with the recursion with factorial iterative. This is the new answer that I give you. You can actually guess that this is actually constant. Why? Let's look at it. So we take the delta as before. All right. Delta means that you take the next one minus the previous one. So 12 minus 6, you get 6. 15 minus 12, you get 3. 18 minus 15, you get 3. So all these numbers are from here. All right. 24 is for the 5. So here is the delta. That is the difference. This delta is allowing us to do the gradient. So these are the gradient. So you see that except for this guy, the rest are all constant, 3. So you can guess that this function, when you differentiate, you get constant, meaning that this function must be what? Bruce. When you differentiate a function, you get constant. What do you think this function is?
It's a linear function.
Yeah, okay. So it's a linear function. So if it is a linear function, then we know that we are going to we're going to we're going to find our k and our n0. All right, so what is the k and the n0? So here is an example of k and n0. I use this function, uh, n plus 3 times 3. So this is actually 3n plus 9. So if I use 3n plus 9, when n is equal to 1, 3n plus 9 become 3 plus 9 is 12. When n is 2, 6 plus 9 is 15, okay, and so on. All right, then what is do I have anything here? Oh, I have. So I know 3n plus 9 is this. If I want to ignore the 9, I use instead of 3, remember we did that, 3n plus 9 is less than 3n plus n for n larger than 9. Then 3n plus n is equal to 4n. So I choose 4n. Okay, so I choose 4n. Then I get this. These are my thing that I get because 2 give me 4n is 8. 3 give me 4n is 12, and so on. Then if you take this function, which is this guy, to minus away him, so what is this? This minus this to give me 6. This is this minus this. So it's trying to compare these two numbers. And by comparing, I get until here, everything is positive, means that this time is bigger. But from here onward, they are all negative, which means that this function is bigger. So I found my function. Let me see whether I have it. I don't have it here. I can then have my k equal to 4. Right? I should move this. Yeah. K equal to 4 because I choose 4n. N0 equal to 9. Why? Because starting from 9. I got 0. Okay, which means that my 4n is going to be on top of my time. So my n0 is 9. Of course, you can choose n0 to be even bigger. Okay, so this is to establish that my function is actually O of n. All right, so I have found a better solution for homework question 7, recitation number 2. Okay, so I'm done with my analysis. So I'm going to give you another practice, which is this one. You can follow what I've done here to find out what is the time complexity. This is actually a midterm, 2020. I was involved in this guy. Okay, I will post this in the forum, and then you can first of all analyze it yourself with what we learned last week, and then use a spreadsheet to see for yourself. At least we should do it once. Okay, but you don't have to do this all the time. But this is a good exercise to reinforce your understanding about time and space complexity, particularly time, because we are getting these numbers out from the Python tutor. Okay, so let me summarize what I had for today and call it a day for myself. But you still have the tutorial number 2 to go on. Okay, let me summarize. Okay, so this is what you have done, or we have done, right? I did this step by step for you to see, and this is at least in our life, you must do it at least once to really appreciate it. Okay, my summaries are this. There are various ways we do graphing. So this is also a form of graphing. All right, so we draw graph. Like you go to the physics laboratory or physics usually, you do measurement with different values and then you plot the graph. Okay, so here we do that. So in particular, a lot of time we deal with whatever it is, it's a looping that is causing the time. That is the wonder of computer program. The sequential doesn't cost you much time. If the program has many looping, then of course we do one by one and sum them up. There is another important message that I had for you in my notes. Debugging effort needed can be inversely proportional to good discipline in programming, which I use in my slide, and you should bear that in mind. Okay, I'm done with my preaching. And any question before I pass it on to your tutor? Yes? Anything? Junjie is here. Anyone? If not, give me a check and then I can go. Okay, great. Great, thank you. And I will make Junjie the host. Junjie, can you say something? Let's see. Can I hear you?
Hi, can you hear me?
Okay. Yes, can hear you. Okay, you can share your screen. I've already make you host. But you start at 8 o'clock, huh?
Yep, can.
Okay, thank you. Okay, bye. I'll see you next week.
Bye.
Bye. I'll leave my machine on just in case. Junjie, you want to share your screen so that I can see?
Yep, I'm setting up.
Oh, I see. Okay. Okay, I see it now. Ajay cannot hear you.
Oops, I forgot to turn on my mic. Okay. Hi, everybody. Can everybody see my screen? Can I get a thumbs up? Right, okay, I'll start the tutorial now. So I've settled on the way that I'll do my tutorial. So to make sure that we can have 1 hour of learning through all the tutorial questions, I'll be basically asking everybody for their thought process, their answers, and for everybody to explain how they got their answer so that everybody can learn from each other and see the different ways that each question can be done. Because each question, they don't have a fixed answer all the time. So sometimes a question can be done like different ways. And it's best that you be able to see all the different ways because like in an exam, like different ways of doing a problem can come up and you need to understand them all. And also don't be afraid to make any mistakes like when you post your answers. Making mistakes here is fine because it's better than making mistakes in an exam. If you make a mistake here, then we can learn from it and you will not repeat the same mistake in exams. So let's start with question 1. Okay, so we define a function magnitude that takes the coordinates of 2 points on a plane as arguments and returns the magnitude of the vector between them. So this question applies a math formula. So these are formulas that you may have learned in A levels, O levels, or poly. Yeah. So there's the formula for the vector between 2 points. So here it is. So when you have 2 points, like A is x1 and y1 and B is x2 and y2, the vector AB is calculated by subtracting the coordinates like that. And this is the vector between the 2 points. And to get the magnitude of the vector, you apply this math formula. So let's see everybody's answers for this question. Yep, try posting with the code feature. It's easier to copy. Right, nice. We have a lot of different answers. Let's go through some of them. Right, so Daniel Lu Ping, can you explain how your answer works?
Yeah, it's just following the formula. You just square root then the y1 minus y2 whole thing square plus x1 minus x2 whole thing square.
Yep. So yeah, over here you take the y1 and y2, you minus them to get your vector. Same for here, x1 minus x2, and use the formula for magnitude of a vector. Yes. Now, every other way basically works the same way for this question. I see a lot of different ways, but it's basically the same process. You apply the two formulas. Okay, I see something here. We have some people who get the epsilon of the distance, but it doesn't really matter because you're gonna square anyways. So even if the difference is negative, it will be squared. And it works the same way. So yeah, if these epsilons were removed, it will still work for this question. Let's see if there's any interesting ways. Yep, this question is quite simple. So basically everybody does it the same way. You just apply the two formulas. Yeah, feel free to go through all the alternatives from all your classmates. We can move on. So question 2. A function can be viewed as a black box. All you need to know are the arguments it can take as input and what its output is. So one way of calculating the area of a triangle is using the formula half times base times height. So can I get everybody's answers to this question? Yep, thank you. So far we are still at the easy questions first, so there's not much to explain. But basically, we are applying the formula, so the function needs to take in the inputs base and height, because that's what are varying in our formula for the area of a triangle. We use the constant half times the inputs base and height, and we can get back the area. So there's basically only one way to go about this. Yep, okay. So now we go on to 2b. So another way of calculating the area of a triangle with sides A, B, and C is using a trigonometric ratio sign. Okay. Basically, we're applying another formula. So can I see everybody's code for this question? We're applying a second formula for getting the area of a triangle. Yep. So this question is also very simple. So you just have to apply a different formula. It takes in 3 inputs, A, B, and the angle, and you just apply the same formula. Yep, and this will work. So now the question is, both functions basically calculate the same thing, the area of a triangle. Can they be directly substituted for each other? So can I see some explanations? Like why or why not? What are your answers for 2C? Right, so what I'm seeing is everybody thinks the answer is no, which is correct. So the reasons are different parameters, different number of inputs, different way the parameters are used. Yes. So basically in these two different functions, they take different parameters. Not only do they take different number of parameters, but the parameters are different. So the first function, it takes in base and height. And that's different from like A and B. A and B of a triangle, sides A and B, are not necessarily the base and height. So even though it may work for, let's say, a right angle triangle, where A is the height and B is the base, we still have a different number of inputs. So if you try to input the base and height into function area 2, you're going to get an error because, right, let's see here. We try to calculate area 2 with like 10, 20. A right angle triangle with base 10 and height 20. You're going to get an error. So area 2 requires 3 arguments and you only passed in 2. Even though like it technically may work because A and B are valid, but you're missing the angle. Let's see if I can get it. Okay, I'm just going to write that. Yeah, so you need to provide the angle also. So even if 2 different functions take in the same number of parameters, sometimes when the parameters are different things, the function cannot be directly substituted. Because if you use the same function, if you use the first function's parameters with the second function that uses the parameters in a different way, you will get a different outcome. So no, the functions cannot be directly substituted for one another. Now, for 2D, we can also calculate the area of a triangle using Heron's formula. So we see this thing over here. Can I see your answers? So Heron's formula has already been defined for you. It's a mathematical formula, a different way of getting the area of a triangle using the 3 side lengths of a triangle. So what you need to do is basically write a function that takes in the coordinates of the 3 points of a triangle and returns the area of a triangle using Heron's formula. Right, thank you all for your answers. I think most of you got it. So, Rayang Chan, can I quickly have you explain how to do this question? How you did it, how you approached it?
Let me have a look. Basically, yeah, just calculate the various values. Then basically I calculated S, right? Then I also calculate like A, B, and C, and yeah, that's it.
Yep, thank you. So basically, to apply Heron's formula, you need the side lengths of a triangle, right? So you use the magnitude function on the coordinates, the input coordinates, so that you will get the 3 side lengths to use Heron's formula. So the reason why you had to do that is because the question wanted you to write a function that only takes in the input of the 3 points of the triangle. So what could be a better way to make the function look better? because it's currently on a very long line. Right, yes, you can take them out and save them as intermediate variables. So it's good to have descriptive names for your variables. So like you can use site so that it's easy to tell from a quick look what each variable is storing. So like site length A, site length B. And site length C.
Okay, Ken, thanks.
Yep, this will be more readable. Especially when like questions get more complicated and your code gets longer. It's better to write more readable code like this. Okay, so now question 3. So this is the code tracing question. So these are code tracing questions are very common themes of questions that can come out in exam. So let's look at the first one. Right. Can I have somebody raise their hand and explain how they trace this question for full one? Right. If nobody raises their hand, I'm gonna pick a random name. Right. Pin Ray Ho.
Yes.
Okay. Can you trace this question? Like how you would do during an exam?
Sorry, I need to take a look. Okay, so first line is like, oh, we have a variable I equals 0, result equals 0. Then it says that for everything that's less than 10, then the result will be added 1. So it basically summing up the numbers from 1 to 9. So sorry, 0 to 9. So the result should give 0 to 9, I think. 0 plus 1 plus 2 plus 4 all the way to 9.
Right. Thanks. So, yep. So basically in an exam, what you should do is you should be able to trace this out in pen and paper. But let's say you don't understand how. So right now you're practicing, you're studying. If you don't understand like how a particular code is run, how it is traced, you can use Python Tutor. I'm sure a prof has showed that before. So what you'll probably do at home will be to copy paste it in Python Tutor. And basically, Python Tutor will show you what the values are. Wait, I had to print full one. And Python Tutor will show you how the variable values like change for each loop. So basically, I will iterate in the loop. It will keep going up until while it's still less than 10. So as we go through this while loop, the value of I will be increased by 1 at each loop, and the result will add the value of the I at that current iteration. So this is a handy way of tracing through a function call, tracing through an expression when you're at home and you don't really understand how to trace it yourself. But if you're in an exam, you're not going to have access to a Python terminal or a Python tutor. So this is how I would do it. So the best way for this kind of question where we have a loop and variables are changing in number. So I will draw a table. So with pen and paper during the exam, I'll draw this. So first, I is initialized as 0. I is 0. Result is also initialized as 0. So result is currently 0. So we'll go through the loop. Well, I is less than 10. So result will plus equals to I. So I is currently 0. Result plus 0 equals to 0. Then I will plus 1. I is now 1. Now, I is still less than 10, so we'll keep iterating. Result will add on the 1. So, and so on, so forth. Now, when I is added by 1 to be 10, the loop will not continue. The loop condition has been broken, and the while loop will end, and we will not hit here. So I will not plus by 10. So the last addition to result is 9. So we will stop at 45. So this is a simple question for now, but as the code tracing questions get trickier, it's good to draw a table during the exam with pen and paper so that you can trace the question. Now, full 2. Anybody want to volunteer? An explanation on how they trace the question? All right, Isaac Lam.
Hello.
Hi. Can you trace this question?
So they start by making the variable I and result 0. After that, going through the while loop. Unless I is 3, then will the whole loop stop. Else, result will keep adding I, and I will keep adding 1. So you'll keep adding from 0 to 2 into result.
Right, so what will be printed?
3.
Yes, correct. So this is the table that you will write in exam. So I starts at 0, result starts at 0. So we'll iterate through the while loop. Go from the first iteration, add 0, then we add 1, then we add 2. But when I plus 1 to be equals to 3, the while loop termination condition is reached. No, wait, no. The if statement is reached. So I equals to 3 will break, and this part of the code will not be ran. And the whole while loop will stop running. And then you return the result. So the last value of result is 3. All right, bar 1. Now, who wants to volunteer for this question? Right, let's have James Lejun Tan.
Yeah, so the for loop goes from 0 to 9. So result will add from 0 to 9 and you'll be 45.
Yep, thank you. So this is the same thing as the first question, just that it's a for loop. So just remember that range works exclusive. If you pass it 10, it's going to go from 0 to 9. Now bar 2. Okay, let's have Julius Ng Tian Tai.
Hello, can you?
Yep.
Yeah, for bar 2, so results is 0 at first. Well, so for I in range 10, it will repeat 10 times. So I mod 3 equals to 1, continue a. So for I, it will start with I equals to 0. So I 0 mod 3 will be equals to 0. So it will continue, then we'll go to the next I. So results will still be 0. Then it will only add 1 when I becomes when I is 1. When I is 1, it will add I to results. So results becomes 1. Then the next I for I mod 3 to be equals to 1 is 4. So results will add 4. So results become 5. Then then the next I will be 7. So 5 plus 7 equals to 12. Then afterwards there will be no I in range 10 that will fulfill the criteria for I mod 3 equals to 1. So the result for the print will be 12.
Okay, that's not quite correct. But I think it's because you don't understand what the continue keyword does. So basically the continue keyword in a loop, you will use it in a loop. So what it does is it skips to the next iteration. So let's say you're currently in like the second iteration of this for loop. So this for loop will normally run from like I goes to 0, I goes to 1, I goes to 2, right? But if let's say you hit the continue within the loop, you will skip to the next iteration immediately, and this code will be ignored. Yeah.
Oh, yeah. Oh, yeah. Sorry. So, yeah, I have the opposite.
Right.
Yeah, so it's supposed to be for any number other than 1, 4, and 7, it will plus I.
Yep, correct. So basically, you start from result equals to 0. So when I is goes to 0, you add 0. When I goes to 1, you don't do anything because I 1 mod 3 is equals to 1. Yeah. And then that will continue. It'll continue and it will skip running this line of code. It will move on to the next iteration. So over here you add 2, you add 3. Now when you are at 4, when I goes to 4, this will trigger 4 mod 3 is equals to 1. So continue. It will skip, you will not add 4. And same thing, when you reach 7, you will not add 7 until you're at 9.
Yeah.
So this should be the table you write in exam. All right, so I have some extra questions for real-world scoping. So good to take a look at them. I'll give you guys like 1 minute to look through. And then I'll ask somebody for their explanations. This is a tracing question. All right, so I'll ask somebody for their answer. Godwin Leonard, are you there?
Yes, I'm here.
All right, so what is the output of this block of code?
Okay, so I talked through my thought process. For print extra 1, 6, so 6 is passed into the parameter x. Y equals to x is basically just saving the value of x, which in this case is 6, into the variable y. But the next line, x equals to y plus 5, is essentially like x plus equal 5 lah. So in this case, I think the output of print extra 1, 6 is 11. Then for print x, it's using the global variable x, which is 5. So I think it will print 5. For print y, it's using the global variable y, so it will print 10.
Yep, right. So what you guys need to understand is how a scoping works. So over here, we have the variables defined in the global scope. And if you're inside a function, functions have their own local scope. So if you were to trace the question exam, you will do it like this. So when you run print extra 1, 6, so 6 is being put in as input to extra 1. So within extra 1, it no longer sees this x equals 5 in the global scope. It only knows the value of x is 6. So within extra 1, its value of x is 6. But if you were to ask it what y is, it will look outwards and see y equals to 10. But now we are overriding it within the local scope. So before this line runs, y is equals to 10 because that's what it retrieves from the global scope. But now when this line runs, it sets the value of y within the local scope of extra 1 to be equals to x, which is currently 6. So when we run this line, y equals to x, we are not getting the x value from the global scope, we are getting it from the local scope, which it knows to be 6. Now, we set the x still in the local scope to be y plus 5. So, x is being overridden again. It takes the current value of y plus 5 equals to 11. So, when we return x is currently equals to 11 within the global scope of extra 1. So 11 will be printed out here. But over here, these lines, we are in the global scope. So it will look for the values of x and y. And this is what it sees. This is what will be printed. And 5, 11, 5, 10. Yeah. So you need to understand how scoping works because it's also a common theme that will be tested in exam. Okay, the next extra question on variable scoping. Now this is just basically you need to understand how for loop works. So let's have Kaisen. Or you explain.
Yes, good evening.
Okay,
Let
so
me tell
what's
you about
the
the
output?
scoping or
What is the output? And explain why.
okay, well it starts from 100 and then for I in range 100 to 102 I plus equals 100. Yeah, I have no idea, man. I have no idea like what this would do.
Alright, okay. It's fine. We'll go through it together so that everyone can learn how this works. It's also a possible question that can come in exam. So how the range function works, it basically returns a sequence of numbers for the for loop to iterate through. So, okay, first, what sequence will be returned? Tyson.
Oh no, okay, I get it now. Wait, is in Python are variable scope to for loops as well? In Python are variable scope to loops as well?
No.
No, okay. Then it's a bit awkward because the range returns a generator that gives you the sequence like 100 and 101.
Yep. 100 and 101. So basically, we start at I equals to 100. We'll loop through the for loop. So there's only 2 iterations. I will be set to 100 and I will be set to 101. So in the first iteration, I is being set to 100 first. Then I will be incremented by 100. So the current value of I will become 200. Then we move on to the next iteration. I will now take on the value of 101. So this will be overridden. I will now be equals to 101 within the scope of extra 2. Then for the second iteration, 101 plus 100 equals to 201. So that will be the final value of I that will be returned.
Sorry, what? I thought you just said that they're scoped within the loop.
Actually, I didn't understand what you meant by that.
As
It
in,
doesn't keep the value only within the loop. So if this loop updates the value inside the loop, the value will be carried forward outside. But it's just that
so it's
because
not scoped within the loop.
yeah.
Okay, got you.
But the thing about the for I in range thing is when we reach the iteration where I is 101,
Yeah, I get to overrides. Yeah.
you'll override, and then the past change to I will basically be overridden, right? Then we will plus I, and then the for loop ends, and then you return I.
Got you. Thank you. To use a JavaScript.
Yeah. Different programming languages can like work differently. In JavaScript, like every single block has its own scope. But for Python, the scope works with functions. So functions have their own scope. And there's the global scope. Yeah. If you all don't understand, it's good to have like more practice with these kind of questions. Okay, but we can move on. So question 4. Write a function sum even factorials that finds the sum of factorials of the even numbers that are less than or equals to n. Let's see. Can I get your answers for this question? Just paste it in the chat. Right, so Kanlim, can you explain your answer?
Uh, uh, so for the first one, the base case is when factorial, like 1 and 0 factorial give back 1. So then yeah, that's the base case. So if you have like a number bigger than those numbers, the 1 or 0, I do the recursion that decrements by 1 every time. Yeah, and then it multiplies. Sorry, the big one multiplies by the decremented by 1 version. And then yeah, it returns that value lor. So it slowly increases. Then for the sum even one, I just have a total that I set to 0. And then I use the function that I declared above, and then just use the range to like use the even number only.
Right, yeah. So what you did here was you use the range, you input step equals to 2. So basically you iterate from 0 to n plus 1 exclusive in steps of 2. So this will basically run iterations of I goes to 0, I goes to 2, I goes to 4, up to n only. So you increment your total by factorial I and only use the even i's. So Tanlim, I'll ask you, what is the time complexity and space complexity of your solution for some even factorials?
N over 2.
N equals to?
N over 2. I'm not sure.
And space complexity?
I think it's a constant because I only use the total as like the placeholder. I'm not sure.
All right, first, can you explain why the time complexity is O n squared?
Because Mm. Is it because the factorial calls back like the sum even calls back like the normal factorial function which like iterates over the different ends, like the each value. So it's like for example, if I want to use 2, then it has to go through like the base and then the 1, which
Actually,
gives
how about we explain it this way? So let's start with the time complexity of your factorial function. What is the time
Yeah.
complexity of this?
That's just n, right?
Yeah, O(n).
Yeah.
Now, how many times does your sum even factorial call it?
Half of n.
Yeah, so when we write out the full time complexity, how do we calculate?
Half n times n, which gives like half n squared, right?
It simplifies to n squared. Yeah.
Yeah.
So you're correct for time complexity, and that's how you explain it in exam. So basically, it's a recursive function, a simple recursive function that has time complexity O(n), and for some even factorials, this line will be ran n divided by 2 times. All the other lines are O1. So like you just hit those points and you get your mark for explanation. But what you said for time complexity, you said O1, right?
No, that's the space one.
What?
For that O1 is for space because I thought like total was just that. Like all my values are just stored in total. So I thought it's constant.
All right, but
Yeah.
that is incorrect because you see some even factorials, it runs a recursive function. So what is the space complexity of factorial?
N.
O(n),
Right.
yeah.
Yeah.
But so if some even factorials runs factorial, it can't possibly have a space complexity smaller than O(n), right?
So it will be O(n) also. Okay.
Yes, it's O(n). Now, the reason why the space complexity of factorial is O(n) is because of the recursive call stack. The maximum size of the recursive call stack is n, because that is the maximum number of function calls stored in the stack for this. So O(n) is the space complexity for here. Now, for some even factorials, you'll run this line n divided by 2 times, but we're not going to keep holding on to the whole call stack for every round of factorial. Factorial I will be called 1 time per each iteration, and then all the memory will be released back. So we're not going to have a space complexity of n squared. We're going to have a space complexity of O(n) because that's the largest size that we'll keep in the recursive call step.
But the more long-winded one would be O(n) plus 1, right? Because of the total. But since like we can just simplify, it'll just be
Yeah,
O(n).
we don't need to worry about constants when we have a n.
Ah, okay. Thank you.
All right, so we have a slightly different way. Let's see. Asher, can you explain your solution?
In my definition of the function sum even factorials, so I first included the function for factorial, which generates the factorial for any number in a recursive manner. And then I use even factorial sum to sum up the sum of the factorials that we need, which are even. And for number in range from 0 to n plus 1, so that will include all numbers from 0 to n. If the number is divisible by 2, meaning the number is even, we will add the factorial of that number to the sum. And then at the end of the loop, we will return the sum.
Right, so what's the time complexity of your solution?
The time complexity is O(n) to the power of 2.
Right, and space complexity?
O(n).
Yes, for the same explanations as above. Right, so this method is different in that you will still run your n iterations, but we will check for a condition. If only when num is even, then we'll run this line. So this line is only run n divided by 2 times. Our time complexity will simplify as n squared, and space complexity is O(n). Thanks guys for providing your answers. It's a good way of helping everybody learn and help to identify common areas of mistakes. And we'll all learn the explanations for time complexity and space complexity. All right, so question 5. So suppose we define these functions. What happens if we perversely ask the interpreter to evaluate the combination FF? Now, can we have Yu Tao? Yu Tao who?
Yes.
Yes. What will happen when we try to run FF?
I think because f is a function that takes a function as the input, right? Sorry.
And
so if we were to like if it takes a function that takes a function as the input that requires it to take a integer as a input to the function that it takes in. So if we were to put ff, then it would result in a type error, I think.
all right, so can you trace it? Like when we run FF, what is the next step in the expression?
So when we run ff, the next step it will result it will cause the integer 2 to be used as a function instead.
Right. So okay, so I'll show you guys the tracing. So basically, like when we run FF, yeah, F is the input to the function F. So basically, you get passed in here, F. So when we return the function called with 2, we'll get F2. So FF becomes F2. And now we go back. What happens when we call F with the input of 2? So 2 goes in here. So G is equals to 2 and return 2. So that will return 2 called with 2. But this will return a type error because in Python, there is no definition for integers to get called with an input. So this is actually function calling notation. So when we put a bracket to the right of something over here, we are expecting it to be a function. So whatever put here must be a defined function, anything like any name function. So if it's not a function, like you pass in anything like a string or a integer, that will cause an error because like there is no definition in the Python language for that object to have any behavior with any inputs. So that's why like Python will get confused and you'll get a type error. Yeah, you don't need to understand you don't have to know and write out this whole explanation in object is not callable in exam. You just need to know it's a type error. So like you can look through the common types of errors like type errors, value errors, and see like the common ways that they will come about. But you must know that there will be an error. Yeah, okay, so basically we reached the end of the tutorial. Thank you guys for participating well. So a lot of you gave your answers for the tutorial questions, and that's a good way of like helping each other learn and seeing all the different ways that you can go about every question, especially when the tutorials get harder and harder and like there are more and more alternative questions for the tutorial questions. It's good for everybody to see all the alternative ways and understand like everybody's different approaches. And some different approaches may have different time complexities and space complexities, especially down the line when we approach like more tougher questions. So it's good to like look through those also and see all the different ways of explaining like all the different time complexities and space complexities. But we reached the end of the tutorial, so thank you guys for coming. And yeah, y'all can go already. Or if you have any questions, you can stay back and ask. Like I'll be looking at the chat. When Sam asked this type of question, like question 5, and instead of model template to answer for open-ended questions or key marking points to know. Well, we don't provide model templates. We don't provide model templates for the explanations for time complexity and space complexity, but we have many past year papers. So basically, all the different ways of explaining time complexities from like O1, ON, ON squared, and for iterative functions and recursive functions, you can find them in the answer sheets. Like those questions basically cover the points needed. So like when it's a recursive function, you need to say like how many times the recursive calls will happen. Or like if it's power 2 to a power n, you need to say like how many times it recursively calls itself per line. See, must we specify type error or is it acceptable if we simply say there's an error? Right, that one we need to clarify with Prof because it depends on his marking scheme year by year.
I think it's I don't expect you to memorize those kind of specific error. You can just state its error. Yeah.
All right, thanks.
Okay.
So for Kayang's question, okay, when we save variables to make the code shorter, like your magnitude example, does it take up more space? No, because for magnitude, space complexity is how the space grows as the input increases. So for magnitude example over here, where we save intermediate variables. Where was it? Okay, here. So over here. So even as the input grows or whatever, we still save a constant number of variables. So the space is constant either way. So it's still ON space. See where to get the PYPs. It's in the work bin on cosmology. It may not be released yet. It's probably has a time for each of the papers are being released.
Let me see. It should be in a work bin. Under training or exam. Under exam, you can see midterm at the bottom and final exam second from the bottom. Also all the rest of the PE.
All right, for Yen Su's question, okay, so for how the time complexity O(n) squared is derived. Are you asking about this question? Okay, so for this question, it makes use of the helper function factorial. So factorial is a simple recursive function. The time complexity for factorial is O(n) because it calls itself recursively n times. And for some even factorial, so total set equals to 0. This is an O1 step. So don't really have to explain that. For the loop, this loop, how many times will the loop run? So from range 0 to n plus 1, step of 2. So this loop will run n divided by 2 times. And it will run this line n divided by 2 times. So this line, we know that factorial takes O(n) time, right? So this O(n) step gets run n divided by 2 times. So the total number of steps being run is around n times n divided by 2. So that simplifies to n squared because the half gets taken out, right? It's a constant. All right, does the reassignment of I value affect the loop conditions? Let's see. What do you mean by that? Oh no, it does not affect the loop conditions. Okay, so basically, what you mean is this loop runs from range I to I plus 2. So this is calculated first. So first we have I equals to 100, right? Then we'll have for I in range I to I plus 2. So we already have this line already sets the loop to run from I equals to 100 to I equals to 101. So this is stuck already. The loop will only run 2 times. So as the loop progresses, it changes I to 200. Then we move on to the next iteration. I is overridden to become 101. Then we run the step over here, plus 100, and it becomes 201. Yes. So it will not make the loop run a different number of times. I can explain the space one for this, for question 4. Right, so we know that for this function, the helper function factorial, the space is O(n). The reason why that is because it's a simple recursive function. So when we have n over here, it'll keep in the recursive call stacks the calls to factorial n minus 1, n minus 2. So like n times fact n minus 1. But to calculate fact n minus 1, you will need to calculate n minus 1 times fact n minus 2. But to calculate fact n minus 2, you need to first calculate n minus 2 times fact n minus 3. So Python will need to like keep track of all this before it finally reaches the base case, right? Down, 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 down until like base case 1. So it will plus 1 and it will go up, up, up. So to keep track of all this, we have the recursive call stack that stores roughly n calls to factorial, right? So that's why the space is n. Now, for here, in some even factorials, we run this line n divided by 2 times, right? But for each line, it will be run fully to get the value of factorial I that will be incremented to total, then the recursive call stack will be freed up. So we will not keep holding on to space until like n to the power of 2 of space. We'll only use on because that is the largest size of the call stack that it will ever be for the entire run of some even factorials for input n.
All right, to add on to that, I think you can use Python Tutor to take a look
All right, let's see.
on the space.
Yeah, so over here you see like factorial will keep like, this is why factorial takes like on space. So like let's say when you call factorial 4, like you need to keep track of four lines in the recursive call stack. But you see, when we like evaluate, let's say factorial 6, right? We'll go all the way down to the base case, but then it will go back up. So now we have our value of factorial 6, but all the space that it had been taking have been freed up, right? So when you go towards the end, the largest size of the recursive call stack is equals to the input n. So like input n is 10. The most space that you'll ever take by factorial is 10, which is scaling linearly with n, right? It doesn't like hold on to all the factorial calls over the entire course. So it's not O n squared space, it's O n space. Right, let's see. Can you quickly go over the for I in range I2? Does the reassignment of I value affect the condition? This question.
Yes, that's the one.
What do you mean by the loop condition? So the loop for this line when it runs, right? So we'll basically iterate from I equals to 100 to I equals to 101. Yeah. So first I is equals to 100. So over here, I is first set to 100. Then when we have the loop condition, because I is in the for loop, right? I will then be set to the first number in the sequence provided by the range function. So I will be overridden to be 100. Then you run the line I plus equals to 100. So I will then become 200. But then you finish the first iteration already, right? So you move on to the next iteration. In the next iteration, for I in range, for I equals to 101, this gets overridden again to be 101. Yep, then you'll run this line plus 100 equals to 201. All right, so do you understand now?
Wait, sorry. Why does I get overridden to 101?
Oh, because of that's how the for loop works. So when you reach the second iteration, right? Because you use I over here for the loop control variable, I will always be set to the current number within the sequence for the range, right? So there's two iterations. The first iteration is I will be set to 100. The second iteration, at the start of the second iteration, I will be overridden to become 101 because you use I over here.
So the value of I is locked in at the start, doesn't change.
the value of I will be overridden at each iteration. So wait, we can do another demonstration. Okay, so what happened if is I plus 3. So where we have here, so I starts off being 100, right? Because of this. Now for I in range I to I plus 3. So basically we'll have I equals to 100. Then the second iteration I will set to 101. Then I will be set to 102. All right. So we start with I equals to 100. Then in the first iteration, I gets overridden to become 100. Then this time runs
Oh, okay,
I.
I get it now. Because the in range already sets the value to be 100, 100, 102 based on the iterations.
Yes.
Okay, thanks.
You can use
Okay.
Python Tutor to visualize how the variables change also.
Okay, I think your question got to do with also this is maybe due to the language itself. If you try C or C++, they could be different. I
I
think
took
in
this
C
from
or C.
functions
Yeah.
tutorial.
Okay, this one Python maybe is this way, but the if you use C or C++, thing can be different. So I can say that this is a peculiarity of Python. Oh, so be careful. This knowledge doesn't transfer to other languages.
Right, understood. Thanks, Prof.
Welcome.
I think this was in a past year paper. That's why it was there.
Yeah, I think so. Yeah. Oh, there was a question just now about what happened if you don't write the best. Is it the Ethan? Was this answer already? Ethan, are you there?
Not yet, bro.
Okay. Actually, the question or whatever question we make, we will state it explicitly in the question. So if we allowed you to get something not the best, you will get the credit. But if we ask you for the best, you better get the best. Oh,
Okay. Thank you, bro.
okay. So anytime when questions are not clear, you can always challenge us. So we will try to protect ourselves. We will make it clear.
Okay.
Okay?
Can. Thank you.
Okay.
Right, for this question, time complexities are all O n squared. Yeah, for reverse, it's because slicing is a O n operation. Basically, it's because you're creating a whole new tuple. So like this tuple sequence, when you slice it, you're creating a new tuple, and that will take O n time. Because like you're making a new tuple. Yeah. Then this is a recursive function. It recursively calls itself n times. So n times n. At each step is a n operation. So overall time complexity is O n squared. Right. Yep, same thing for here. List slicing or tuple slicing, string slicing is a O n operation. Then accumulate recursively calls itself n times. So n times n. Yes, if it's I plus 3, it will give 202. If for very young, so you ask like the I from 1 equals to 100 is ignored when you add 100 to it. No, it's because like when you set I equals to 100 first, then when you run this for loop, right, it starts the first iteration as I equals to 100. So it sets I to be equals to I, right? So like it stays 100. Then you run the line, it plus 100 becomes 200. Then for the next iteration, I equals to 101. This gets overridden. I becomes 101. Then you add 100 to it. Becomes 201. Then the last iteration, I gets overridden. I gets overridden to be 102. Then you run this line, plus 100, end up with 202. That's why.
Okay, you guys still come back to this question. Actually, if you look carefully, a range is an object. So the range is an object which is defined to be when I equal to 100. This is an object from 100, 103. So this is already set once you enter into the for loop. So whatever you did to the I plus equal to 100, that statement is not going to change the object range. So that's why Junjie has been explaining that it got overwritten. Actually, it is because the object itself has been defined to be from 100 to 103. So that one cannot be changed. All right, because the association of the I has already been replaced with 100. All right, so if you think in that way, you take a Google a little bit about range, you will find that range in Python means an object. You will release the value one after another. Okay, what is this question? I have a question about time complexity at the beginning. For the time complexity, it was either 2n was 4 and it was. Oh, actually, when you write O of 2n and you write O of 3n, actually they are the same as O of n. All right, so both actually is the same thing. So both are actually the type bound for the case of a linear. We usually don't write O of 2n, O of 3n. We just need to write O of n. All right, k doesn't make any difference in theory. Okay. Junjie, are you done or you are still waiting
Yep.
for?
I'm done already. I think
Oh,
everybody's questions have been answered.
oh, I see. Okay, okay, I'll leave also. Bye bye.
All right, bye.